In this video, we further explore rules for differentiating logs and exponents. And we'll start by rehashing some rules we've already established in previous videos and then use them to tackle some examples. So, to recap, we've established that the derivative of e to the x is simply, e to the x. We've also established that the derivative of ln of x is 1 over x. Third, we've established that any number a raised to the power of x, that's simply a to the x times ln of a, which is only valid for a greater than 0. And then finally, the derivative of the log base b of x is simply 1 over the quantity of x times ln of that base b. So in our first example, we must find the derivative of 3 to the x times, what's in this parentheses right here. So we apply the product rule and we have the derivative of the first term, which by rule 3 is 3 to the x times ln 3 times just the second term as it is, plus the first term times the derivative of the second, which we go term by term. And for the first term, the power rule gives us 2x. And for the second term, the last rule that we went over gives us 1 over x times ln 10, and then plus the derivative of a constant, which is just 0. And this whole expression is our derivative, and for this example we're done. In the next example, we're given two composite functions. We have e to some function, which is x squared, and then ln of some function, which is sine x plus 5. And we're asked to find the derivative of this whole expression, which we should find the derivatives of each one of the terms right here. And so with each term, we apply the chain rule, and the application of the chain rule of the first term leads to e to the x squared, which is just the same function over again, times the inner function, which by the power rule we have 2x, plus the derivative of the second term, which the derivative of the outside function, the ln of some function, is 1 over that inner function, times the derivative of that inner function, which is cosine of x plus 0. And this entire expression is the derivative that we're looking for. And with the second example, we're done. And that concludes this portion.